project is handwritten Chinese character recognition based on CNN. Team members are Li Jia, Wenman, Yufan. We have 5 parts. Let's start. The first part is introduction. At present, the research of Chinese character recognition technology is mainly divided into 2 categories: printed Chinese character recognition and handwritten Chinese character recognition. Handwritten Chinese character can be divided into offline recognition and online recognition. Because there is no stroke order information and the photo scanning device is under different lighting, resolution, writing paper, and other conditions, it will bring some certain noise. In general, offline handwritten character recognition is more difficult than online. In the past, many scholars focused on feature extraction. However, there is still no satisfactory method. In recent years, with the rise of deep learning, deep science has become the architecture of the choice for complex vision recognition problems. It has shown that well-constructed deep science are powerful tools to solve these challenges. And our technology in our project, the CNN is unsupervised self-learning sampling and no manual feature extraction, so it's very convenient. Our target. In this project, we will explore the power of deep CNN on the classification of handwritten Chinese characters in offline model. Now let's start the second part, the data set. For this project, we use the CSIA offline database. The CSIA offline database are developed by the Chinese Academy of Science. Especially, we will use the HWDB 1.1 dataset, which totally includes 3755 Chinese characters and 107 alphanumeric symbols. The data consists of plain grayscale images of isolated handwritten Chinese characters.
Now I want to introduce the general structure of our project. This project has 3 main steps. The first step is data processing and then build the model. Next, we will training and validate. What I want to mention is about the top K accuracy. This accuracy outputs the probabilities of the test imaging belongs to each class in descending order. If the true label belongs to the top key class, we consider it's correct and calculate the corresponding accuracy. What I want to focus on is the model. In our project, our group used the convolutional neural network as our model to train and test the datasets. The general structure of this model is shown on the right. This model has 3 different types of layers, which are commonly used in convolutional neural network. For convolution layers, we aim to set the thread parameters equal to 3. In the process of building this model, the project will change the output depth in order to get more accurate result. After that, we use the maxi-pooling layer. This layer extracts the most useful feature and discards the others. In addition, this layer can reduce the spatial size of feature map and keep most prod output unchanged, even though some changes happen to the input, like small translation. Then we aim to use fully connect layer. This function of this layer is similar with the classification. As we have mapped the input data into feature map through the last two layers, convolution layer and max input layer, using the fully connected layer will help the model to do the form classification work. In addition, this layer will make sure all neurons and will make use of all neurons, and this action help to improve the correctness of final output. This project uses two fully connected layers. The first one has 1024 neurons, while the second one has the 3755 neurons. Because the second one is connected with the output layer, so it needs to classify the data into this different class. More importantly, in order to prevent overfitting and reduce the computation complexity, the fully connected layer will use dropout technology. Finally, we aim to use softmax as our output handle layer to calculate the final probability. As the output range of softmax is from 0 to 1, this action is suitable to compute the probability. And then the sorted probability can give us the final class that every data belongs to.
Let me talk about details of our project. Step 1 is data pre-processing. In TensorFlow, the type of input data should be tensor. So in the first step, we should convert images and labels to tensor by using building function. During model training, we use some data augmentation methods like changing brightness and contrast of images randomly to add some noise on training data, enhancing the generalization ability of the model. After that, we resize images into a normalized size, divide them into batch, put them into a queue, and shuffle them. When training or testing model, we get data from the queue directly. Step 2 is build model graph. We use a library called SHENG to build this model. SHENG is a library that makes it simple to build, train, and evaluate neural networks. It can eliminate many of the repeated code in naive TensorFlow, making the code more compact and more readable. We choose IDEM as optimizer, which is a combination of RMS probe and momentum, and use cross-entropy loss as loss function. The accuracy of the model is calculated in two different ways: top 1 accuracy and top k accuracy. Step 3 is training. Training step contains two parts: training and testing. We use training data to train the model, and at the same time, we use testing data to test the accuracy of our model. During model training, we first use function input pipeline to pre-process the training and testing data. Then we use function build graph to build the model. If the model has been trained before, you can choose whether to restore from the latest checkpoint and continue training, or just train from scratch. Each step, you print the loss of the model. Every 50 steps, the model will be evaluated by using test dataset. Every 500 steps, the model will be saved as a checkpoint. The process of validation is very similar to the training step. We use test dataset to evaluate top 1 accuracy and top k accuracy of the model, and save the results in the output file. Final, I will talk about the results of our project. You can see from the graph, with the increase of training step, the accuracy rate is also increasing. From the scatter plots of the previous page, we can see that with the increase in the number of training steps, the accuracy rate is also increasing. But because the data size is too large, the computer power is insufficient. We only carried out 16,000 steps. So the final accuracy rate is showing as follows. Thanks for watching.